Is it okay?
Hello. Good evening, everyone. Actually, we are extremely fortunate today to have with us a distinguished individual who has made significant contributions to our field. I am honored to introduce Mr. Brahmeshwara Rao sir, Senior Electric Vehicle Trainer in ISIE India as volunteer based. He is having 5+ years of experience in the domain of academics, research, and trainings. Earlier, he has served as project head and researchers in various parts. So, I would like to request you, sir, that to start this session. Thank you.
Good evening. My name is V. Brahmeshwar Rao. I am audible?
Yes, sir, you are audible.
Okay, okay, fine. Is the screen is having full screen mode? Is the screen is visible to you? PPT.
Yes, it's beautiful, sir.
So screen is visible
Okay.
but not in full screen mode.
Once confirm. Hello.
You are audible and screen is visible.
Okay, okay, fine. Okay. So my name is V. Brahmeshwar Rao. I completed my Master of Technology in Advanced Power Systems from JNTU Kakinada, Andhra Pradesh. I started my career in IT CPSPD Patrachalam as a apprentice trainee in there, and then I joined as a junior engineer in Ramoji Film City. And later I started my career in academic, that is educational field, and worked as assistant professor for 10 years. And then recently, from 5 years, I am working on this solar energy and that electric vehicles construction, design of electric vehicles. This is a brief introduction about myself. Uh, Today, I am going to give a small webinar on these fundamentals of electric vehicles and photovoltaic systems. Uh, so we will start with the basic. Okay. So how this electrification was done in electric vehicles, that we are going to learn. Is it audible?
Hello.
So I need some reply
Hello.
from you. Yes.
Sorry to interrupt you, sir.
It's audible.
Can you reshare your screen?
Okay. 1 minute. Okay.
Yes, sir. You can proceed, sir.
Okay. Thank you. Good evening to all. Today we are going to learn about the fundamentals of electric vehicles and photovoltaic systems. Now we will start with the first slide. The journey of automotive industry. Okay. So before the first, we are having internal combustion engines. Okay. At that time, there is no self motor. Okay. Purely it is a mechanical based engine. That is, we need fuels for to run the mechanical load. Okay, that is called 0% electrification. Here we are having 0% electrification. There is no any self motor also at that time. We are putting some rod to start the internal combustion engine, that is diesel engine or like that. Okay, and later onwards, what happened means we are having the introduction of self motor to start the vehicle. That is here starter assistance. For that we put some electrical components in the auto, that is vehicle. Okay, automotive automobile, this one. Okay, so this is a little bit modification, electrification done. and later we are having introduction of this mild HEV, and we are having this is called fuel cell hybrid electric vehicle, and this is range extended electric vehicle, uh, and also this is purely battery electric vehicle. Okay, 1 minute. Okay, this is how the electrification was done in the different times. Okay, so now we are in the at this stage battery electric vehicle, 100% battery vehicle, because we are using that battery as the source for running the motor in the vehicle. Okay, this is 100% battery vehicle. Okay, so what is happening here? Mild, this is HEV, okay, and fuel cell hybrid electric vehicle, range extended hybrid because if you take only battery, what happens means the range will be very little compared to that internal combustion engine. So if you fill a car with 35 liters of fuel, it will run for 600 to 700 kilometers. Whereas compared to this battery electric vehicle, it will run only up to 300 to 400 kilometers, depend upon that battery capacity. Okay, that is the disadvantage present in the battery vehicle, and also the time taking for charging the battery is also, it takes a little bit more compared to the filling of fuel in the normal vehicle, that is the internal combustion engine, diesel engine or petrol engine vehicles. Okay, so why we are going for this battery electric vehicle means in order to reduce the greenhouse effect. What is greenhouse effect? You already know about greenhouse effect. That is the temperature of the surface of the earth is going, it is increasing day by day because of the pollution coming out from the fuel engines. So in order to reduce that temperature, we need to stop using of that fuel, that is petrol or diesel engines. We have to reduce that consumption of fuel. Okay, so that the carbon production in the Earth's surface will reduce, and also temperature will come down. That is the main focus of this. That is shifting from fuel to electric vehicles. Okay, is it audible?
Yes, sir.
Hello. Okay. Okay. So now we are going having different configurations of electric vehicles. Okay, what is present in the electric vehicles? Major components are one is the electrical machine, that may be a BLDC motor or PMSM, that is permanent magnet synchronous motor, or we are having some other motors also there. Okay, so BLDC, PMSM, like that we are having different motors that comes under electrical machine to run the powertrain. Okay, and we are also having ECU, electronic control unit. Okay, so this is for giving power to the motor. Okay, we are having three-phase BLDC motor like that. Okay, for generating three phases from DC supply. If you are having DC supply, for DC supply we are having two terminals. One is positive, another one is negative. Okay, so from that positive and negative, we need to produce three phases. Okay, so for producing three-phase supply from the DC battery, we have this electronic control unit. The purpose of this one is to make change of supply from DC to three phase. Okay, and with some frequency control also, because we need to control the speed of the vehicle. Okay, that can be controlled by accelerator throttle. Okay, okay. Next one is battery pack. Okay, this battery pack is very similar to fuel tank in normal vehicle. Okay, so what is the purpose of battery pack means it can store the energy in the electrical form. Okay, so the purpose of this battery is to charge, that is one, it has to store the energy in the electrical means. Okay, so we are having two types of supply, one is AC, another one is DC. Okay, already we are using AC supply in our homes. So what is the frequency in India is, it is 50 hertz. Okay, so what is the supply coming from the battery, whether it is AC or DC? Anyone can answer? The supply coming out from the battery is AC or DC? Anyone having knowledge?
DC, sir.
It is this.
Oh, yes, DC.
DC.
Okay, it is DC because what is the main difference between AC and DC? In DC we can store the energy. Okay, but in case of AC, alternating current, we can transfer it for a long distance, okay, with minimum losses. The advantage in AC is we can transmit the power for long distances with minimum losses, okay. And the advantage in DC is we can store the energy in battery, yeah, in the chemical form, okay. So the best example today we are using in the India is lithium batteries, okay, for electric vehicles, okay. There are so many other batteries also there, nickel cadmium and other some other are also there, but most of the electric vehicles they are using lithium batteries, okay, lithium ion batteries, okay. So battery pack consists of uh, n number of batteries connected in series to get required voltage. For example, if you need 48 volts for a vehicle, then each lithium ion battery is having a 3.8 volts. Okay, maximum voltage is 3.8 and minimum is 3.25. Okay, so depend upon the maximum voltage, we will connect n number of batteries to get 48 volts. Okay, so all these are monitored by the series connected lithium ion batteries in the battery pack are monitored by battery management system. What is the work of this battery management system is it will monitor the voltage of each lithium ion battery which is present in this battery pack. Okay, so what is the function means, what is it will do means it will monitor the voltage level of the lithium ion battery. Okay, if it is fully charged, then it will bypass that section and charge the other battery which is having lower voltage, lower than the maximum voltage. Okay, so what happens if you charge a lithium ion battery above the maximum level means it will get heat up and burn out. Okay, so to prevent the battery pack from fire accidents or overcharge, okay, this battery management system is very useful and it helps the battery to uh, give long life. Okay, so main function of this one is to monitor the level of charge. Okay, so whether it is crossing higher voltages or like that, then it will stop the charging. Okay, if it is going above the maximum level, then it will stop charging. Another section will be charged up. Okay, because we are connecting n number of batteries in series. Okay, so what happens if in between one battery is overcharged means it will get heat up and that will fire out. Entire battery pack will damage. Okay, so to prevent that battery pack from fire, this battery management system is very, very helpful and it is very essential for lithium ion battery pack. Okay, what is power converter? So we are using 48 volts DC. Okay, so for headlamp and other things we need only 12 volts DC. Okay, for horn like that, auxiliaries are present in electric vehicle. So in order to step down that 48 volts from 12 volts, this power converter will be helpful. Okay, what is inverter? Inverter means it will convert DC to AC. Okay, in some vehicles like grid connected electric vehicles are there. Okay, so at that time the energy stored in the battery pack is given to the grid when there is a need of energy from grid. Okay, so this inverter will help like that. Okay, regenerative braking system. Okay, for this the best example is if a vehicle is moving with some velocity, it is having some kinetic energy. Okay, if you apply a brake at that time, what happens, friction will come at the breakdown. Okay, due to that friction the vehicle stops and heat will be generated at the wheel. Okay, so if you use that kinetic energy for in the means of friction, more heat will be generated. Okay, so what we will do means in the regenerative braking system, we will use that kinetic energy and that inertia to generate power and given back to the battery. So whatever the kinetic energy or the stored energy in the moving vehicle, that can be used for generating power and that power is given back to the battery. That is called regenerative braking system. In this braking system, most of the kinetic energy will be used to charge the battery and rest of a little bit for stop the vehicle. That is at the last friction will be applied and brakes are the vehicle will be stopped. Okay, so the kinetic energy is given back to the battery. in this regenerative braking system. Okay, is it clear? Hello, is
Yes,
it clear?
sir.
Okay.
Yes, yes, sir.
Next, coming to the front engine rear wheel drive conventional electric vehicle powertrain. What is powertrain means? The part where the mechanical energy generated is given to the wheels. That section is called powertrain. Okay. In this diagram, we are having a engine is here. This is flywheel, and this is clutch, and this is gearbox, and this is final differential box. Okay. So, and this is the rear wheel. Okay. So here the mechanical energy is developed in the engine. Engine means it has it may be a, internal combustion engine, or it may be a electric motor. Okay, in case of electric vehicle, it is electric machine. Okay, so here the mechanical energy is generated, that is given to the flywheel, and here we are having clutch. From here to here, the mechanical energy is given to the wheels. Okay, this is the powertrain section, which is having a flywheel, clutch, gearbox, and this is propeller shaft, and this is differential. Okay, so here what is the use of flywheel means it can store the energy, kinetic energy. Okay, in some later slides we will get flywheel application. Okay, clutch, we already know what is the purpose of clutch. When we want to apply brake, or when we want to change the gear from higher to lower or lower to higher, at that time we need to isolate the engine from the transmission. Okay, this is gear. The propeller shaft should be isolated from the engine. Okay, at that time only gears can be changed and brakes also applied. Okay, depend upon the situation. Okay, if you want to apply brake, or if you want to change the gear, then we need to isolate the engine from the gearbox. For that, clutch is used. Okay, that is the purpose of clutch, to isolate the engine from gearbox. Okay, and what is the purpose of differential here means when you are taking the turning. Okay, at that time the vehicle wheels will not run at the same speed. Okay, suppose if you are going in this way, this wheel has to move more RPM, and this is having low RPM. Okay, so there is a RPM difference is there between two wheels. Okay, this will happen only at the curvature. Okay, at the turning point of the road. Okay, at that time we have to run with more RPM here and less RPM here, a little less. Okay, not very much. Okay, for that this differential will help. Okay, whatever the propeller shaft, the mechanical energy coming from the propeller shaft, that is given more to the outer wheel, and less to the inner wheel. Okay, that is the purpose of differential present in the rear wheel axis. Okay, so this is the main function of differential, which will helpful in the turning of the road. Okay. Next, gearbox. You already know. We already know that gearbox will help in increasing the speed of the vehicle at plain roads. Okay. So for up climbing, that is for up climbing roads, we need a low gear. That is one. Okay. So at that time, the mechanical power given to the wheel will be high. Okay. Hill climbing. Okay. Next, on the flat roads, that is we need speed, high speed. At that time, we go for fourth gear or fifth gear, like that. Okay, where speed will be more and torque will be less. Okay, when in case of first gear, torque will be more at the wheels, and speed will be low. Okay, that can be done by the gearbox. Okay, depend upon the situation, we go for more torque and we go for high speeds. Okay, when you are going for up, that is when you are going for hill climbing, we need more torque. Okay, at that time we go for first gear. First gear will give more torque and low speed. Okay, in case of flat road, we go for high speed. Okay, we prefer high speed. Okay, when there is no dropping. Okay, at that time we go for higher gears, that is fourth gear or fifth gear. In that fourth or fifth gear, what happens here, the torque to the wheels will be less and speed will be, the RPM will be more. Okay, that is the function of gearbox. Okay, use of gearbox. Okay, in case of some vehicles, we are using mm, some like today we are having gearless vehicles also there. At that time they use only clutch. Okay, Now, next, this one is conventional electric vehicle powertrain. Okay. So this is a normal vehicle. Okay. Now, this is the conventional electric vehicle. Okay. We want to land here. What is there in this one means battery pack and a DC to DC inverter, and this is DC to AC converter, and here electric motor. Uh, so whatever the energy present in the battery pack, that is given to the electric motor, where that electrical energy is converted into mechanical energy. That mechanical energy again given to the differential or the mechanical transmission, which consists of gearbox, differential, all those things comes under the mechanical transmission. Okay, and then given to the wheels. Okay, this is a normal layout of this electric vehicle powertrain. Okay, how the power is coming? The power is coming from battery pack, and then is given to the inverter and converter section, and then given to the electric motor, and then from electric motor we get mechanical output, but mechanical output is given to the mechanical transmission section, which consists of clutch, gearbox, again all those things present in the ICU. Okay, gearbox and differential. Okay, this mechanical transmission block consists. Next, this is the drive wheel, which may be front wheel or rear wheel. Okay, that cannot be that will be depend upon the vehicle. Okay. Next, coming to the configurations of electric vehicles. Okay, you are having different types. Okay, first we are having this C stands for clutch and D for differential, FG for fixed gearing, T for transmission, M for electric motor. Okay, if you see the first one, which is having here electric motor, that is given to the clutch, and then from clutch to the transmission, transmission to the drive. Okay, and this is the wheel. Okay, which may be rear or front wheel. Okay, and next this is the steering. Another configuration is there. Okay, where the motor is connected directly to the transmission, and this is the differential. For this, the best example is now we are seeing Mahindra electric vehicle autos. We are having Mahindra autos, three-wheelers. Okay, there we are having electric motor directly connected to the transmission, and then we are having differential. Okay, that is the best example. This is for four-wheeler type EVs. We are having clutch also there. Okay, and next is coming to the third ones. We are having motor, and one is fixed gear, and this one is differential. Okay, so this is also very similar to this one. Okay, what is the difference between here and here means here we are having transmission. Transmission means gearbox. Okay, so here we are having fixed gear. That is, there is no change of gears. Okay, directly the motor is connected to the differential with some fixed gears. Okay, transmission will have gear system. Okay, that clutch and this one. Okay, and next coming to the fourth configuration, we are having motor with fixed gear directly connected to the wheel. Okay, so here we don't have any differential. Okay, two wheels having two different motors. Those are connected to the wheels with fixed gear FG. Okay, so in this, what will happen if you are going to use this type of vehicle at the turning? What happens means one wheel the inner wheel should have low RPM, and the outer wheel should have higher RPM, as discussed earlier now. Okay, so for this, what we will do means we will put some controller. Okay, that controller will give more frequency for this outer wheel and low frequency for inner wheel in order to have low RPM here. Frequency and RPM are directly proportional in BLDC or PMSM motors. Okay, so like that, the frequency can be monitored by that control unit, which is connected to the steering. Okay, later in another slide I will show that. Okay, and next coming to this one, another configuration, that is motor is connected to the wheel fixed gear, similar to this one only. Okay, next this one is motor directly connected to the wheel. Okay, there is no fixed gear. Okay, so for this motor directly connected to the wheel, the best example is all those two-wheelers we are using now having this motor in the wheel. Okay, in-wheel motor we will say. Okay, next coming to the another slide, in-wheel motors in four-wheel drivetrain. Okay, so now I have told something here. Okay, for driving these wheels at a different RPM. This is the slide. Okay. Oh. So here the motor is connected to the wheel and another motor is connected to the wheel. We are having four motors at four wheels. Okay, and those are independent controllers we are having. Okay, the motor supply is given from the controller. Okay, like that. Four outputs coming from the controller. Those outputs are controlled by this steering. Okay, then we are having some feedback from the steering. Okay, so when you take turning like this, the outer wheels, this one should run with more RPM and the inner wheels should run with low RPM. Okay, so in order to have that RPM differentiation, we need to give some feedback to the controller. Okay, so that according to the steering position, the RPM of these outer wheels will be increased. Okay, that is the purpose of this green line. Okay, if you turn like this, then the steering will be moved like this. Okay, and the RPM of these outer wheels will be more and the inner wheels will be low. That can be decided by this green path coming out from the steering. Okay, this is the feedback path, an electrical signal coming out from the steering box given to the independent controller. Controller is nothing but which can control the power to the these motors, BLDC motors in the present in the wheels. Okay, so this is in wheel motor. The example that I want to tell here, that is here. Okay, next coming to the energy supply. Okay, so to run electrical motor we need some electrical storage device. Okay, that is battery pack or fuel cell or uh, another one is flywheel. Okay, we are having a super capacitor and hydrogen reformer. These are energy resources for a vehicle. Okay, so in case of pure electric vehicle, we have only battery pack. Okay, in case of some combinational vehicles are there, that is a fuel cell electric vehicle or flywheel electric vehicle or super capacitor, like that. There are combinations. Okay, hydrogen cell electric vehicle, like that. There. Okay, in that for suppose if you take the first configuration, what is there here? Battery, converter, load. Load means motor. Okay, here the load is in the every diagram. The load is nothing but motor connected to the wheel simply. Okay, because motor will convert electrical to the mechanical. Okay, so battery will give the electrical energy and this converter C will convert that DC to the three-phase supply, and then this electrical motor will run, and now the wheels will move. Okay, the wheels will run. Okay, with some torque and RPM. Okay, coming to the second configuration, here having two batteries. Okay, battery 1 and battery 2, those are connected to the converter. Why? Because if battery 1 is having it was discharged, battery 1 is discharged, then we can replace this with another battery, and battery 2 is again in life. Okay, just like two cylinders gas connection. For an example, I am saying. Okay, they are having another spare battery here. Okay, B1 and B2, those are connected to the converter, and then here load. Okay, in order to increase the capacity. Okay, mileage. Okay, and coming to the third configuration, we are having fuel cell and battery. What is the fuel cell function means? Here we are having another diagram. Okay, so fuel cell also will supply the energy and battery will also supply the energy. Okay, from fuel cell also we will get the energy, electrical energy. Okay, in the next slide we will learn. Okay, whatever it may be, here the converter will take electrical energy and that is given to the load. Okay, and the wheels will run with some torque and RPM. Okay, next coming to the fourth configuration, that is hydrogen reformer and fuel cell, both are used, and here another way battery is used. So all here also we will get electrical energy and here also we will get electrical energy. Those are given to the converter. Depend upon the availability of the energy in the battery will be used. If the battery is not having sufficient energy, then fuel cell and reformer, these are coming to the picture. Okay, after the non-availability of the energy in the battery. Okay, so like that the energy can be shared between these sources in this configuration. Okay, here also the same thing. If the battery is not having sufficient energy, then fuel cell will come into the picture and that will share the load. Okay, like that the sources will share the load. Okay, in the different configurations. Coming to the last, this one E configuration. Here we are having super capacitor, and here we are having battery pack. Okay, so if battery pack is having sufficient energy, then battery pack will supply the electrical energy to the load through converter. And if the battery is discharged fully, then supercapacitor will come into the picture and it will give the supply to the converter and then goes to the load. Load means electrical motor connected to the wheels, which will have some torque and RPM on the wheels. Okay. Next, last configuration. This is having flywheel. Flywheel means nothing but a heavy mass connected on a simple frictionless bearing, so that when we are having some kinetic energy on the wheels, that can be shared to the flywheel. This flywheel also move with the same RPM. When there is additional energy required after the discharge of battery, at that time the flywheel with kinetic energy, the kinetic energy of the flywheel is converted into electrical energy and then given back to the converter to the load. Okay, so flywheel will store the energy in the form of kinetic energy. Okay, it is having some inertia with heavy mass. Okay, just like suppose we are going in a vehicle, suddenly brake applies means what we will feel, we will move a little bit forward and we will hit on the another seat, front seat. Okay, so this is because of the inertia present in the mass. Okay, so like that this flywheel is also having some inertia, kinetic, and that inertia will give some kinetic energy. That kinetic energy is converted into electrical energy, and then it is given to the converter to the load. Load means again electrical motor connected to the wheels. Okay, so this is the energy given by the different sources in different configurations. Okay, okay.
Yes, sir.
Okay. Next, this is the fuel cell energy system with a hydrogen reformer. Okay. So here fuel tank is there, and here a reformer is there. And when air is given to the reformer with the fuel means it may be a gasoline. Okay. These two combine and will give hydrogen and with some carbon dioxide as the output. Okay. So this will produce, reformer will produce hydrogen for supporting the fuel cell. Okay, what is happening in the fuel cell? A fuel cell will take hydrogen and air and it will give some mechanical output. Okay, that the mechanical output will give some electrical output. Okay, hydrogen and air will mix up and it will give electrical output. That electrical energy, 1 minute, that electrical energy is taken to the inverter and then go to the load. Or if there is any excess electrical energy which is not used at the wheels, when you apply brake, at that time the battery pack will charge, and again when there is a need, and the battery pack will deliver electrical energy to the inverter via fuel cell. Okay, so like that fuel cell will give electrical output by taking the hydrogen and the air as the input. Okay, the function of fuel cell will be explained in the later slide. Okay, so what is the disadvantage here? If you have hydrogen directly, then there is no problem. But if you want to produce hydrogen in the vehicle itself, you need reformer. Reformer again will generate carbon dioxide. Okay, this is some a little bit. Okay, we are not. This is in the application. Okay, rare applications we go for this one. And next. Main function of this electric vehicle is depends upon the battery pack and load inverter. Okay, main this will supply the battery pack will supply the electrical energy to the load. In case of non-availability of the storage energy, then this fuel cell will come into the picture and it takes hydrogen from this reformer. Like that, it will extend the range. Okay, the main purpose of this using fuel cell here is it will extend the range of this vehicle. Okay, like that fuel cell will help to extend the range of, that is to increase the mileage of the vehicle. coming to the combination of super capacitor and battery pack as energy sources for electric vehicle. Okay, this is another configuration. Okay, so we are having battery pack. So mainly this will supply the electrical energy to the motor through via this one converter. So in case of non-availability of electrical energy at the last, that is discharge, okay, fully discharged position, at that time supercapacitor will come into the picture. It will give the electrical energy to the uh, motor via this one DC to DC converter and DC to AC converter. Okay, so this will extend the range of this electric vehicle with normal battery pack. Okay, the only main purpose is to extend the range. Okay, so coming to the here, the energy will goes to the battery. Energy will come from the battery to the motor here continuously, and here if you take a supercapacitor, energy can be charged or it can be discharged depend upon the load of this motor. Okay, peak power supply. When you want to hill climb, at that time you need more energy. Okay, more torque. So for producing more torque, we need more energy. Okay, so that is called peak power supply. Okay, so supercapacitor will give that peak power supply from here to here. Okay, when you produce when you want to have more torque in the hill climbing situations. Okay, so acceleration is more in plain roads, and acceleration will be less on hill climbing, and torque will be more. Okay, in case of at the at the starting of a vehicle on a plain road, acceleration will be more. Okay, that acceleration and torque later I will discuss on the next slide. Okay. Two types of flywheel arrangements used in electric vehicles. Okay, one is flywheel is connected to the clutch and then goes to the gearbox and then goes to the electrical machine. Okay, this is one configuration. Mechanical energy from the flywheel convert to the electrical energy. Okay, and next in the case two, mechanical energy from the flywheel propane the transmission directly. Okay, there is no conversion from mechanical to the electrical in case of second one. Okay, so if you take that this first picture, this flywheel is having some kinetic energy. Okay, inertial due to inertia. That kinetic energy is given to the gearbox and then given to the electrical machine. Okay, and here electricity is supplied to the motor and accelerate the flywheel. Okay. Coming to the second diagram, here the kinetic energy due to the inertia is given to the gearbox and clutch and directly to the transmission. Okay, so there is no presence of electrical motor or anything in here. Okay, transmission means nothing but rear differential with connected to the rear wheels. Okay, here in case of the first section, it is having gearbox connected to the electrical motor, and electrical motor again then given to the the presence of electrical is here. Here the absence of electrical machines will be there. Okay, so where efficiency will be more, I think here the efficiency will be more because lesser parts will have more efficiency. Okay, that is the advantage. Next, power distribution for an electric vehicle. Okay. So the power output of electric propulsion, that is, it may be a BLDC motor or PMSM motor. Okay, whatever the motor present in the electric vehicle, the power output is mechanical output. That mechanical output is used for power for acceleration, power for hill climbing, power for surface rolling resistance, power for aerodynamic drag, and another one is internal losses. Okay, that mechanical power losses in the transmission and power to accelerate rotating components, power for auxiliaries. Suppose the vehicle is at rest. Okay, and we are starting with some key. Okay, at that time, what should be the power of output of the motor to make a vehicle at rest to move. It is at rest, and we are going to make that into move. Okay, so at that time, more torque is needed by the electrical motor. Okay, so for that, more torque means it need more acceleration. Okay, so the acceleration power for acceleration means it need more torque. Okay, because it is at zero speed and we need some RPM. Okay, So acceleration will be more at the starting. Okay, that is power for acceleration. This is more in the this power diagram. Okay, and power for hill climbing. Hill climbing means already it is moving, but we are having some up. Okay, at that time the torque will be little bit more compared to this one. This is from rest to movement, and this is movement to hill climbing. Okay, so here the power for hill climbing will be a little bit less than power for acceleration. Okay, and another one is power to surpass rolling resistance. Rolling resistance means it is for the resistance between wheel and the road. Okay, so here the friction between road and wheels will be compensated by this one, power to surpass rolling resistance. Okay, so when you move a vehicle on a road, what happens? The road will have some friction. Okay, that frictional forces are compensated by this one, power to surpass rolling resistance. Okay, it is less compared to these two. Okay, these two will work for movement of vehicle. This is for only for friction. Okay, friction will be very less compared to these two. Okay, and next power to overcome aerodynamic drag. Okay, so our vehicle is having certain area, the front portion area, that may be a smooth surface, or sometimes it may be a box type. Suppose if you take different types of vehicles as an example, suppose if you take bus, the windshield will be plain. Okay, and if you take cars, that is four wheelers, the front portion will be a curved surface. Okay, so when you pass wind with some velocity on these surfaces, which one will have more force on the surface? Bus will have the bus or truck will have more force. Okay, so to overcome that aerodynamic drag or air forces, the force due to the air is called as aerodynamic drag. It will be more in the truck and bus type body vehicles, and it will be less in the car. Okay, that is having some zigzag models. Okay, K type. We are having different shapes for the cars. Okay, suppose if you take a Wagoner, it will be like that, and some suppose other vehicles will have different shape. Okay, uh, depend upon the body shape, this aerodynamic drag will change. Okay, so it will be very less. Okay, and coming to the internal losses, power losses in the transmission. Okay, so when you transfer power from electrical motor to the wheel, we are having different sections. One is the main section is transmission. Already we have seen here. Uh, this is transmission. Okay, here in the engine may be electric motor or ICU. Okay, from here to wheels we are having transmission. Okay, this is having some losses. Okay, the power losses in the transmission will be more in the three different losses. Okay, and power to accelerate rotating components, this will be less compared to this one. Okay, and a little bit power for auxiliaries, we are having some auxiliaries, that is the brake fluid, to create pressure in the brake fluid and other things. Okay, so these are the use of mechanical energy coming out from the electric motor. Okay, so like that the electric motor output, the mechanical energy output of the electric motor used for first main purpose is power for acceleration and power for hill climbing, and these three will always high compared to all these things. Okay, this is less and this is very less. Okay, so efficiency will increase when you reduce the losses. Okay, how can you reduce the losses in transmission? Periodically we need to change the gearbox oil. Okay, and we have to check the accelerating rotating components, and also auxiliaries. Okay, is there any short circuits like that? Okay, or any struck up in the bearings or like that. Okay, bearings also having some friction losses. Okay, those are comes under the power for auxiliaries. Okay, so this is the power distribution for an electric vehicle. Okay, that is mechanical output is distributed like this. Okay? Efficiency here is power at the wheel, these three things. This is the output, divided by this one. Okay. So when it will be high means when these losses are low.
காத்தத்துல யாரோ ஊத்துறதா சொன்னேன்.
Next, power train configuration for a range extended electric vehicle. Okay. So electric vehicle consists of battery pack and inverter, and this is an electric motor, and that is given to the transmission line. Normally, the energy to the electric motor is given by the battery. Okay, so when battery is not sufficient to for the expected range, at that time this range extender is used. Okay, what is there here means we are having internal combustion engine, so it will run by using the fuel, that is gasoline or petrol or diesel, like that. Okay, so when there is a uh, options of this energy in the battery, at that time internal combustion engine will come into the picture and it will give the energy to the electrical machine. Okay, sorry, the shaft of the electrical machine, so that the transmission will run and the vehicle will move. Okay, like this. Okay, so main, the battery will give the supply to the electrical motor and it will run the vehicle. In case of absence of electrical energy or the storage of the discharge of the battery, at that time this internal combustion engine will come into the picture and it will give the mechanical output directly to the shaft of the transmission, shaft of the electrical machine, and through that the transmission will be run. So here we are having uh, this one is a internal combustion engine. So this engine will have an electrical machine. So when there is mechanical output from the internal combustion engine, that mechanical energy is given to the electrical machine. Electrical machine acts as generator here. Okay, in this block. So what happens? Mechanical energy is given. Electrical energy comes out from the generator. The difference between generator and motor is uh, a machine can act as a generator when it takes mechanical energy as the input and electrical energy as the output. Then it is called as a generator. And a machine can act as a motor when it takes electrical energy and gives mechanical output. Okay. So if you take this diagram here, internal combustion engine will give mechanical output. Okay. So that mechanical output is given to the electrical machine. What happens to the for the machine having a input mechanical energy, it will give electrical output. Okay, so here the electrical machine is acting like as a generator. Okay, giving three-phase supply to the AC to DC converter, and again this AC to DC converter will convert three-phase AC to DC, and this is given to the DC link of the battery. Okay, like that here. Okay, so, uh, 1 minute, 1 minute now.
Okay, basic को दोनों बढ़ाओ ना, पर ढाई यार दोनों बढ़ा दो ना.
बेटे खूबसूरत छुट्टी है तो खूबसूरत तुम छुट्टी है तो आज फिर तो छुट्टी है ना सैटरडे तो.
Okay, coming to the fuel cell, we are having here fuel cell. For that, we will give hydrogen as the input and air as the input. When hydrogen and air is coming to the fuel cell, at that time, this electrolyte membrane will produce some chemical reactions, so that because of this chemical reactions, electrical output will come out from this fuel cell. We can see here. Here we are having H2, H2. Okay, it is splitting into four H plus ions, so that we are having 4 electrons on these hydrogen molecules. These electrons goes to here, and coming to the here air. Air is consisting of oxygen. Again, oxygen is splitting into 4 molecules, and we are having positive ions here. So those are coming to here, and these like that electrons and protons in this fuel cell will make some electrical energy coming out from the fuel cell. Okay, that electrical energy is given to the DC to DC converter. Again, this is given to the battery of another vehicle. Okay, which is having fuel cell based range extender. Okay, and the excess hydrogen will come out here, and after the chemical reaction, this hydrogen and oxygen will convert into H2O, water. Okay, this water will not harm anything in the environment. Okay, this is environment friendly here up to here. Okay, so if you produce hydrogen by using the reformer, there you will have again carbon dioxide, but that is another way. Okay, for producing hydrogen, we have some another materials. Okay, we will put electrodes in the plain water, distilled water, so that will also produce hydrogen gas. Okay, that will be discussed somewhere at some time. Okay, so now hydrogen gas is directly used with input air, and here the electrical energy is coming out from the fuel cell. Okay, that electrical energy is given to the battery. So again, the battery will charge and it will supply the uh, electrical machine, and transmission run the wheels. Schematic of the fuel cells. Okay, and this is the two types. Okay, proton exchange membrane of fuel cell and alkaline fuel cell. In case of proton, okay, so hydrogen, air as the inputs, and we have excess hydrogen here and water as the output. Okay, in case of second alkaline fuel cell, only water will come. Okay, there is no excess hydrogen. Okay, and whatever the hydrogen given to that fuel cell and the air will combine together and form some electrical energy. That electrical energy is given to the load or converter, and only water will come out. Okay, in case of alkaline fuel cell, we have only water as the output. Okay, in case of protons exchange membrane fuel cell, we have excess hydrogen coming out from the chamber of this fuel cell. Okay, that is the difference between two types of fuel cells. And powertrain system for a fuel cell electric vehicle. Here we are having fuel tank, and that fuel will supply to the fuel processor and controller, and then here fuel cell. Uh, Here we are having battery, inverter, electrical machine. What you have seen here only, the same thing. Okay, this will be explained more in this diagram. Okay, fuel tank will give the gasoline or whatever it will be. This is the fuel processor, and similar to reformer, which will produce hydrogen from normal fuel. Okay, that hydrogen is given to the fuel cell, and also oxygen given to the fuel cell. Here electrical energy is generated. That electrical energy is given to the converter and then goes to the inverter and to the battery. Okay, so like that electrical energy output of this fuel cell is going to the battery via converter and inverter to battery. Again, whatever the energy stored in the battery, that will be used when we run the vehicle. From the battery, the energy is going to the inverter and then goes to the electrical machine. Like that, energy power will be going like this when the vehicle is moving. Okay, when the battery is charging from gasoline, at that time fuel tank to fuel processor, the fuel will be supplied, and here hydrogen will be generated. Hydrogen will be converted, hydrogen and oxygen will be converted into electrical energy, and that is given. This is another power diagram. Okay, so what is the purpose of controller here means it will monitor the temperature by thermal management, and the thermal management will have signals to the controller, so that controller will reduce the intake of fuel supply, and proportionally produce the output hydrogen gas to the fuel cell. Okay, if there is more temperature here, then at that time the hydrogen coming out from the fuel processor will be reduced. Okay, so in order to reduce that fuel hydrogen gas from the fuel processor, we have to control the fuel supply to the fuel processor. Okay, that can be managed by this controller connected to the thermal management. Okay, waste heat will be dissipated. What happens if we do not dissipate the waste heat means the machine temperature increases, and due to high temperatures, expansion of the metals, and everything will be damaged. Okay, always heat loss will be dissipated. from any machine or any computer, any other system. Even we laptops also having some cooling systems. Okay, that will dissipate the waste heat coming out from the that is current losses in the processors. Okay.
चलते दुकान में करने चले बाबा चलो
Solar power electric vehicles. So what is the purpose of using solar energy? Anyone? We have seen different types of energy sources here in the previous slide. What are the energy sources here? Uh, Battery pack, hydrogen reformer, fuel cell, flywheel, supercapacitor. All these will have to charge from another sources only. Okay, there is no direct source here. Okay, so coming to the photovoltaic systems, that is the solar power electric vehicle powertrain configuration. We have energy from the sun rays. Okay, that is solar energy. Okay, which is focused on the photovoltaic cell. And the photovoltaic cell converts that sun rays into electrical energy. Okay, direct from the nature. Okay, that is given to the battery to charge the battery. Again, when the battery is charged, normally vehicle will run through the converter and the motor and the gearbox. This is wheels. Okay, this is the differential symbol. Okay, so B stands for battery, which is present here. D is for motor drive. This one, and G for reduction gear. This is the gearbox. Okay, M is the electrical machine. Okay, this is M is the electrical machine. Okay, this motor drive. This is present here. This is differential. Okay, photovoltaic cell PVC, which is here. Okay, this is the normal layout of the solar car. Okay, a conventional solar powered powertrain. Okay, solar powertrain with maximum power point tracking. Okay. So if you take the curvature, that is the characteristics of photovoltaic cell, it will be like the curvature. Okay. So we are having 1 minute. I will show that on the characteristics of. Okay. Later I will discuss. This okay. So here in this slide, maximum power point tracking. Maximum power point tracking means the solar panel will have some dynamic characteristics. Okay. So in the dynamic characteristics, we are having maximum power. Okay, at peak, the peak of the curvature. Okay. So in order to trace that point, we are having a MPPT converters. Okay. So it has some algorithm. The algorithm will trace the maximum power from the panel. Okay. That is the purpose of using maximum power point tracking converter here. Okay, it will take the maximum power coming out from the panel and gives to the battery. Okay, so I will give another lecture on that maximum power point tracking. But for remembrance here, you need to learn that the main function of this MPPT is it will take the maximum power from the solar panel to the battery, because if you take solar radiation throughout a day, it will increase or decrease at the time to time. It will change. Okay, so in the morning session it will be low, or any further instant. Okay, the cloud may come onto the surface of Earth. Okay, because of that variation in the radiation, the characteristics of the panel will change from time to time. Okay, so at every time it has to draw maximum power. Okay, so in order to have that maximum power, to draw maximum power to the battery, we have some maximum power point tracking converters. Okay, so that will trace the maximum power to the battery. That is the function, because from time for every instant of time the radiation will change, the output power will also change. Okay, the output of panel will depend upon the radiation input. Okay, directly proportional to the radiation input. Okay, so when radiation changes, what happens to the output? Automatically the radiation power output also will change. Okay, so if radiation is low, power output of the panel will be low. If radiation is high, power output of the panel will be high. Okay, in general we are having two types of panels. Okay, So I will discuss here. This is the maximum power point tracking. Okay, we are having slide also here. So the characteristics will be like this. Okay, this is the curvature of the solar panel. Okay, so voltage will increase when radiation increases. Okay, and it will come like this. Okay, and the current will also increase like this. Okay, this is the curvature of the current, and this is the curvature of the voltage. When you multiply voltage and current at this point, we are having maximum power. Okay, so this current is with respect to some radiation. Okay, and this voltage is also with respect to some the same radiation. Okay, so the radiation in a day will change from with time. Okay, so every time what happens, we are having a different curves. Okay, for another time we'll have another curve for low radiation. For higher radiation we'll have the curve like this. Okay, if the radiation is very poor means the current curvature will be like this. Okay, and the voltage will for the radiation which has a low amplitude, at that time the current will decrease. The current curvature will be like this. Okay, and the voltage will be here. Open circuit voltage will also decrease. Okay, so the radiation when radiation increases, the current curve will go upwards, and the voltage will also increase. So the power output at this point also increases. Okay, the power is mainly depend upon the input radiation on the panel surface. Okay, um, here, what is the working principle of solar cell means we are having conduction band and valence band and the conducting materials. Okay, so when radiation falls on this material, solar plate or PVCl, what happens? The electrons present in the valence band moves to the conduction band. So what happens in the electrons in the conduction band? These are free. Okay, so this will give negative charge and this will give positive charge. The difference between positive charge and negative charge will create some potential. That potential is nothing but open circuit voltage. Okay, fill factor efficiency. Efficiency is defined by the electrical output of the panel divided by the radiation given to the panel. Okay, in the numerator we are having the electrical output coming out of the panel, that is V into I divided by power output divided by input radiation. Okay. So what is the radiation in India means we are having a curvature here. Okay. So this is 1 square meter will have 1000 watts of power in the radiation. Okay. So normally we are having two types of panels. One is monocrystalline, another one is polycrystalline. Okay. So monocrystalline will have higher efficiency in generating electrical power, and polycrystalline is having a little bit less efficiency compared to mono. Here it is 16% efficiency. Here it is 15%. Okay, that is the difference between. Sorry, here it is 16%. Mono will have 16%. Poly will have 15% efficiency. Okay. Next. Here there is some differences between monocrystalline and polycrystalline. So while seeing the panel, any panel, you have to decide whether it is mono or poly. Okay. So when the panel is having blue color like this, then it is polycrystalline panel. Okay. So when the panel is having a black color, then it is monocrystalline panel. That you can differentiate by seeing. Okay. Coming to the characteristic differences, monocrystalline will have more expensive. Cost is also high, and it is more efficient. Solar cells are black color, and here solar cells are blue in color. Okay, the life is 25 years for any panel. Okay, we are having different companies which are giving these, which are manufacturing these panels. Okay, and next, this is the radiation picture. Okay, in Rajasthan, we are having more solar radiation energy. Okay, and coming to other parts, we are having some little bit less. Here, very less in I think Impal, something. Okay, Itanagar. So it is very less. Okay, in other parts, we are having more. These are radiation energy available from the solar panel. radiation. Okay, in kilowatt hours per meter square per day. So, in which position we have to place the panel to get maximum solar radiation on the panel? Okay, for that we need to know about azimuth angle and elevation. Okay, so elevation is nothing but suppose if you look at this position of the panels, we are having the panel is having some elevation. Okay, so this elevation angle from the ground surface is decided by the location of the this panel on the surface. Okay, so this is called elevation angle. Okay, azimuth angle means the angle measured from the north pole. Okay, we are having north and south axis. Okay, so from there we are having some azimuth angle. Okay, by using this azimuth angle and elevation, we will get maximum power. Suppose if you take now it is February. February means we are having what, September. Okay, this is the line where the sun will be having some inclination angle between north and south. This is the north and south axis. Okay, and this is the east and west. Okay, so we are having sun will rise from in the year the sun will change from the different directions. Okay, the rise of sun will change from northeast to southeast. Okay, you know that, I think this is the middle. This is exactly on the east. Okay, so this is will be on southeast, and this will be on the northeast. Okay, in the zone. Okay, like that it will oscillate. Okay, depend upon that azimuth angle will change. Azimuth angle mainly depends upon the direction of the rays of the sun. Okay, the direction of the rays of the sun will change from time to that is a month to month. Okay, every month the sun will rise at different positions. Okay, this is the 23.5 degrees from March to December. Okay, and from December to again March there is a coming back to the same position. Okay, again from March to June it will move 23.5 degrees towards south side. Okay, like that it will change the positions. Okay, this will be the exact east. This is the azimuth angle changing from 0 to 23.5, again coming back to the 0, again minus 23.5 degrees. Okay, this spike here. We are having three different types of power plants for solar. One is a rooftop solar power plant, another one is ground mounted and floating type. These are all used for giving electrical power to the grid, not for the vehicle. For vehicle, we have to place like this one. Because vehicle is moving, it is not a stable one. Okay, this is for the vehicle we are having flexible photovoltaic cells which are placed on the surface of the body of the vehicle. Okay, so this is about solar power electrical vehicle powertrain configuration. Okay, is there any doubt regarding any topic? Hello. Hello.
Sir.
Okay.
Sir. In the maximum slides, we have seen that we are providing the AC supply to the motor. So, is that can we run it by the DC motor or directly DC supply? Though I know that the current rating will be very much high. So this is the only things, or anything else is behind that?
First, I want to know that your question is why we are not using DC motors. Why we are giving AC supply to the motor?
DC supply.
Yes. Because if you are going for DC supply, we need brushes in the commutator, and all those things are rubbed out when the time is going on. Okay, we need maintenance for brushed DC motors. Okay, so in order to avoid all those maintenances in the timer, so we go for brushless DC motor with three-phase supply. This is also DC, but pulsated three-phase.
Okay. So another thing is that in the steering system, in the more or less some slides before, you have talked about the steering system. When we move the steering, so the rear wheels, the speed of the inner wheel and outer wheel are different. So, sir,
Yes,
in
yes.
this one, so in that case, uh, the steering, the signal from the steering, it is the mechanical signal or anything electronic
Uh,
signal we can convert it.
what happens means when you move the steering, we are having sensors behind the steering. Okay, a steering box will have some sensors, so that may be a resistance type, bridge type sensors are there. Okay, so that sensors will give electrical signal to the independent the controller block. Okay, so
Okay.
the controller block will give again control the motors. Okay, outer wheel will have more RPM, inner wheel will have a little bit less RPM, so that the turning will be safe. Okay, the vehicle will be safe in the turning position. Okay, that you have to keep in mind. Okay, when you are going to take a turn like this. Okay, suppose if you want to turn like this, vehicle means the outer wheel will should have displaced more. Okay, and the inner wheel will displace less. Okay,
Yes.
rotation will be less. Okay, so at that time only it will be safe. Okay, if both are in equal RPM, what happens, it is hard to take turn. Okay,
No,
so
my question is, yeah, that is fine. This
hmm,
signal is the steering signal that is given
yes,
to
yes,
this
yes,
front
I got your
motors.
point. How this
Mm.
steering will take the control over this
Yeah,
RPM.
yeah, yeah,
Okay.
yeah, yeah,
Yes,
yeah.
here we are having some transducers, okay, which will convert mechanical to electrical. Okay, what is transducer? Which will change one form of energy to the another form. Okay, we are having
Okay.
transducers here. Okay, piezoelectric like that. So many transducers are there. So depend upon the situation and the manufacturing design, we are having transducer. That transducer will give information regarding this position of the steering to the controller, which can in the form of electrical signals only.
Okay.
Okay.
So
Mechanical
according to
to
that
electrical.
signal, the
Mm.
PWM of the
Ah,
each
yes,
motor
yes.
will be decided.
Controller will give more frequency signals to the high RPM wheel and low frequency signal to the low RPM. Okay. The
Okay,
speed
that
of the
means
motor will
friction.
depend upon the frequency, directly proportional to the frequency.
Okay, so that means frequency is the main factor that can control the speed, not the
Yes, yes.
PWM control. Okay,
Ah, PWM means which will control amplitude of the voltage.
voltage. Yeah.
Mm,
Okay, thank you, sir. Thanks a lot.
thank you. Anyone? Any more question?
Yes, sir. I have one question
Yes. Yes.
regarding regenerative brake.
Okay.
In regenerative brakes, it is a energy conserving device, what I understood. And
Mm.
what will happen if your batteries are already full and you apply
Mm.
brake, then there would not be any load. Therefore,
Mm.
brake may not get applied. Is it not so?
Mm. 1 minute, I will coming to that slide,
Yeah.
regenerative braking, so that I can communicate. Okay, here regenerative braking is there, but there is not coming.
This one, earlier before first slide. Uh,
Okay, so
look,
Here also we don't have any. Okay. Coming to here, in case of regenerative braking, this one is having regenerative braking system.
Yes,
Okay?
this one. So exactly, this slide is having regenerative brake system.
Okay. So
Yes, my question is from
purpose
here.
of using regenerative braking is whatever the kinetic energy, how when regenerative braking is applied means after the use of battery only regenerative braking system will come into the picture. Okay. So when vehicle moves, so automatically it takes energy from the battery. Okay.
Yes, yes.
So after the absorption of energy from the battery, it is having less. No, it is not fully charged. Okay. So it may be 98% or something 99 like that. Okay. So after completion of 1 or 2% of energy from the battery, you are going to apply brake. Okay. Not at the starting point, you will not apply any brake. Okay. If you apply brake at the rest position, there is no presence of regenerative braking. Okay. So when the vehicle is moving with some kinetic energy, okay, with some velocity, at that time if you want
Yes,
to apply brake,
okay.
no, in case of normal brake, what happens, friction is applied to the brake drum. Okay, so entire kinetic energy of the wheel will be converted into friction and heat will be generated at the brake drum. This is normal brake system. Okay, so in case of regenerative braking system, the kinetic energy in the wheel is given back to the generator type. The mode of the electrical machine will be converted into generator. Okay, so that the energy in the inertia energy in the wheel is given to the electrical machine, which is acting as generator in the regenerative braking. Okay, the whatever the motor will now act as generator in the regenerative braking system mode. Okay, so the energy present in the wheel now goes to the battery through generator.
Generator.
Okay.
Yes.
Yes.
Same. The same battery. Yes, exactly.
Yes, same battery. Because the energy coming from that battery is driven to the wheel, given to the wheel. Okay,
Yes.
so it has already discharged a little bit, 1 or 2%. Okay,
Yes,
so
yes.
again
Yes,
the
yes.
energy
Got
coming
got-
from the wheel is going back to the battery.
Yeah.
But here in this case, if you have 2% is used, only 1% is charged because loss will be
Yeah.
there
Loss
coming
is
back.
there. Yes, yes.
Okay. So whatever the 2%
Got
discharge,
it, sir.
it will not charge 2%.
Yeah.
Okay, that you have to
Yes.
keep in
Got
mind.
it, sir.
Okay,
Yes,
there will be
yes.
loss
Got
in
it, sir. Thank you. Yes. Thank you, sir. Thank you.
reverse
Got
flow.
it.
The power. Thank you. Thank you. Okay. Anyone?
Hello, sir.
Hmm.
Am I audible?
Yes.
Yes, sir. I wanted to ask about the PV cells. That uh, if we have a rooftop solar system, let's say if we have a solar rooftop system, what we do is we actually when we use the system, we send the electricity produced by the solar to the grid directly. So if
Yes.
we are getting the energy in the DC form from the solar, why do we send it to grid? Why don't we store it into the battery for use?
Okay. The main problem in DC is storage. Okay. For storing, we need a DC supply, but the batteries will have some maintenance. Okay. If you take our normal inverter battery, every 5 years you need to change with a new one. Okay. Every 6 months you need to pour some water. Okay. There is some maintenance issues. Okay. In the storage of energy in the DJ batteries. Okay, so that is the main problem. And another one is the lithium ion batteries are also there, but it is the storing of energy, electrical energy in the batteries is not fully used to nowadays. Okay, there is a availability of batteries, but we are not going to use that storage here. Okay, always because it need maintenance. Okay, the problem of maintenance will
Yes, sir.
not giving preference to the battery storage.
Okay, sir. Then the batteries which we use in the electric vehicle as of now are DC batteries, correct?
Yes,
So can
and
we use?
they are also costly. Lithium batteries are costly and need more expensive. Okay, we are seeing that some schemes were given by the government. What they are saying, payback period. Okay, so what is payback period? Whatever the investment you have put on the panels will come back in 3 or 4 years. Okay, as a income. Okay, so if you put investment on batteries, what you will get? You will not
Okay,
get
sir.
anything. It will not generate
Sir,
anything to you. It will not generate any income to you.
okay. Sir, I
This
have
was the
another
point.
question regarding the same point. Is that
Okay.
can we use this solar energy directly to to charge the electric vehicle because it is already having DC batteries, correct?
Yes, yes, yes. This is also giving DC, but we need some DC to DC conversion techniques. Okay, we need some battery. That is, the battery will have 48 volts. The panel will have 36 or 33 volts. Okay, there is some DC to DC conversion. Okay, buck converters or boost converters or buck boost converters. Okay, depend upon the situation, we can use. Okay, we can charge the electric vehicle batteries by using these solar panels with some DC to DC converters. There is no problem in isolated areas where there is no grid power supply.
Then, sir, if we want to develop a
Hmm.
solar-based charging station,
Hmm.
then what aspect should we consider for that? If the we don't want to include the grid and make it a standalone
Okay,
system.
actually, in the isolated area, you need to put yes.
Yes,
It
sir.
is isolated from normal supply, government supply. The
Yes, sir.
area is isolated from government supply. At that point, you need to put a charging station. What are the factors you have to consider? That is your question.
Yes, sir. We are not including the grid. We
Hmm.
are
So
only
at that
directly from.
place, if you see this structure, we are having a building here. Okay, the shadow of the building or any other tree or anything should not fall on the panel surface. Okay, the panel should be kept at a place where there is a full availability of sun rays. Okay, so if you see all these things, there is a hill behind the panels. Okay, not in front of this one. Okay, the shadow of this hill should not fall on the panels. Okay, in the daytime. Okay, so like that, you have to select a place where there is a full availability of sun rays from morning to evening without any shadow of hill or tree or adjacent buildings, like that. Okay, if you have a building, then you have to place it on the building top. Okay, suppose our house is having a ground floor and surrounded by 2 or 4 floors buildings around my ground floor house, means I cannot put solar panels on my top of my ground floor house, because my house is surrounded by first or 2 floors buildings, so their shadows will come onto my surface. Okay, so shadows should not fall on the surface where you are going to put the panels. Okay, that you have to first notice point. Okay, that is, and you have to calculate wind load. Okay, what is the wind air velocity? Okay, by keeping on that wind load on the panels, you have to take the structure strong. Okay, if the wind load is heavy, means the structure should be strong on the roof. Okay, this is the rooftop, so always air will have more pressure on the building top. Okay, compared to ground. Okay,
Okay, sir.
this system will have structure. This is having a weak base, and this should have very strong base. What is the difference between rooftop, ground mount, and floating? Means in case of floating type, the temperature under the panel is very low and the temperature above the panel is very high. Because of this factor, it will generate 6 units per day. Okay, compared to these two, this will generate 5 units per day, and this is having 1 unit more, 20% more efficient here. Okay, the efficiency of the floating type solar power plants is more compared to these two. But here also there is no maintenance disadvantages there, because
Okay, sir.
we need to go here. Okay, under that, if you want to some have any repair, there is some little bit cruciality in the maintenance compared to these two. Okay, thank you.
Yes, sir.
Anyone? Will you identify which type of panel? All these things. These are color in blue, polycrystalline. Okay.
Sir,
References?
Okay.
Can we get a references which you have referred for this? Or
You want material or any?
uh, paper references, whatever you have referred here, or else if it's videos.
Actually, I have taken from my previous what is that workshop? I have attended some workshops. Okay, anything I will share with the ISI sir. That is
PPT also fine, sir. No problem. PPT
PPT.
also fine.
You can get this material from your this my
Organizer.
IIT. Okay. Hmm. Okay. Any more? Any? You can get all these things in only available online. Okay. You can ask team members. Okay.
Thank you, sir.
Thank you.
So, concerned team, please take the call from here.
Yeah, sure. So, first of all, thank you, sir, for hosting the webinar. Your expertise and insights were valuable for our learners, and thanks, learners, too, for attending the webinar. I hope this webinar helped you out to upskill your learning and skills. So, I would just like to take the opportunities to introduce our company ISIE India products and the services that we offer in electric vehicle technology with small video. So, please have a look.
As we are living in the fast changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, e-bike design challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Day Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youth for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQ courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero Motocorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Calcutta's University, Sharda Universities, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide. With India rapidly moving toward an electric-only future, ISIEINDIA is well positioned to develop a workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks, learners, for watching the video patiently. So, any of you want to enroll in the electric vehicle courses or interested to set up COE labs in the institutions, kindly send us inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Everyone, thanks for the joining.
Madam,
Yeah.
these computer science students or IT students can get any training or internship or else project for their academic.
Yeah, sure. Firstly, you have to just scan this QR code and mention your details. The counselor will get back to you by 24 hours
1 minute.
to guide you. Is it okay?
Yeah, means counselor in this is from your end, counselor.
Yeah, from our companies.
Okay.
Will they guide you?
ಎಲ್ಲದಕ್ಕೆ ದುಡ್ಡು ಕೊಡೋದು ಸ್ಕ್ಯಾಮ್ ಎಲ್ಲ ಹೆಂಗುಂಡಮ್ಮ ಬಂದ್ ಮಾಡಿದ್ರು ನಾವು.
Hello, ma'am. Hello. Hello.
Hello.
So this is Jnana Kumar.
Yes, sir.
Can I get the detail about for the center of